Have you ever wondered what everything around you is truly made of? The chair you're sitting on, the air you breathe, even your own body, it all comes down to tiny, invisible particles, smaller than anything we can see. These are the fundamental building blocks of reality, the quantum core of our universe, quietly shaping everything in existence. Imagine a world where particles behave like tiny dancers, spinning, leaping, and existing in multiple places at once. Strange as it sounds, this is the world of quantum physics. It governs the smallest scales of nature, where ordinary rules fade and new, fascinating possibilities emerge. Here, the ordinary transforms into something extraordinary. And even the tiniest elements reveal infinite beauty. But why should we care about particles we can't see? Because they shape everything, from the light in distant stars to the technology in your hands. Understanding these core elements can transform how we perceive the universe and ourselves. In this journey, we'll explore quarks, electrons, and the forces that hold them together. We'll uncover the elegant patterns and surprising oddities that make the quantum world mysterious yet breathtaking. We'll discover how particles, in their subtle movements, create everything we experience and every wonder we witness. By the end, you'll see the universe in a whole new light, one particle at a time. You'll feel connected to the rhythm of existence, understanding that even the tiniest, invisible elements have a story to tell. Each particle is part of a dance older than time itself, a story written in the very fabric of reality.
Section 1. What are quantum particles? At the heart of everything in the universe lie quantum particles, tiny, almost magical pieces that combine to form everything we see. Imagine breaking down matter into smaller and smaller pieces until you reach something so small it almost feels like it's not there. These are the quarks, electrons, and other fundamental particles, the true core of reality, quietly shaping everything around us. Quarks are the building blocks of protons and neutrons, which make up the nuclei of atoms. They come in different flavors, with names like up, down, strange, and charm. Each quark dances in a delicate balance, bound tightly by the strong nuclear force. One of nature's most powerful yet invisible forces. Without quarks, atoms could not exist, and without atoms, the world as we know it would simply vanish. Electrons are lighter, yet equally fascinating. They orbit the nucleus of atoms in invisible clouds, following patterns that seem almost like choreography in a cosmic ballet. Unlike quarks, electrons can exist in multiple states at once, a phenomenon known as superposition, a mysterious, almost magical behavior that defies our everyday intuition. Their presence creates electricity, light, and the chemical reactions that sustain life, connecting the tiniest particles to the grandest experiences. Beyond quarks and electrons, the quantum world contains an entire family of particles, each playing a crucial role in the grand orchestra of existence. Photons carry light across the cosmos, neutrinos whisper silently through matter, and the elusive Higgs boson gives particles mass, anchoring them in reality. Together, these particles weave the intricate fabric of the universe, each performing its role with elegance and precision. Even though these particles are invisible to our eyes, their effects are everywhere. The light that warms your skin, the electricity powering your devices, the chemistry that sustains life, all arise from these. Section 2. Forces that shape the universe. Particles alone do not build the universe, they need forces to guide them. The universe has four fundamental forces, invisible yet immensely powerful, shaping everything from galaxies to atoms. These forces are the quiet directors of the cosmic dance, orchestrating every movement of particles in a calm yet precise rhythm. Gravity, the force that pulls planets, stars, and galaxies together, seems gentle but governs the largest structures in the universe. Without it, the cosmos would drift apart in chaos. Electromagnetism, by contrast, controls the interactions between charged particles. It shapes light, electricity, and magnetism, linking everyday experiences to the quantum world. Then there's the strong nuclear force, which binds quarks together within protons and neutrons. This force is unimaginably powerful, holding the core of every atom intact. Without it, matter as we know it would disintegrate into nothingness. The weak nuclear force is subtler, yet essential, driving processes like radioactive decay and fueling the stars that light our universe. These forces work in harmony, creating balance across scales both immense and minuscule. Imagine them as invisible threads connecting the tiniest particles to the vast cosmos, each one essential to the fabric of reality. Through them, electrons orbit nuclei. Planets revolve around stars, and galaxies hold their elegant shapes. Understanding these forces allows us to see the universe not as chaos but as a precise, interconnected system. The way they shape matter and energy gives us insight into everything from how your computer works to why stars shine for billions of years. In the quiet elegance of these forces, the universe tells its story, a story written in invisible lines of energy, delicate yet infinitely strong. Section 3. Quantum Oddities. The quantum world is full of surprises, defying our everyday expectations. Particles can exist in multiple places at once, a phenomenon called superposition. They can become entangled, meaning a change in one instantaneously affects the other, even across vast distances. These oddities may seem impossible, yet they are the true nature of the microscopic universe. Superposition challenges our sense of reality. An electron, for instance, does not travel a single path but exists as a wave of possibilities. Only when observed does it choose a state. This delicate dance reminds us that the universe is not fixed but fluid, filled with endless potential. Entanglement is even more astonishing. Two particles, once linked, remain connected regardless of distance. Change one, and the other responds immediately. Einstein called this spooky action at a distance, yet experiments confirm it, revealing a deep, hidden order in the quantum world. Other phenomena, like quantum tunneling, allow particles to pass through barriers as if they were ghosts. Particles can behave as waves, waves as particles, and all of this unfolds silently in the microscopic realm, unseen but profoundly influencing the universe. These oddities are not just curiosities, they have practical implications. Quantum mechanics powers modern technologies, from lasers to semiconductors, and promises revolutionary advances in computing and communication. By studying these strange behaviors, we gain both wonder and mastery, bridging the gap between mystery and understanding. The quantum world invites us to see differently, to embrace uncertainty and marvel at the elegance hidden in invisibility. Each oddity, strange yet precise, reminds us that reality is far more wondrous than it appears at first glance. Section 4. How quantum mechanics affects our world. Though invisible, quantum mechanics shapes our everyday life. From the devices in your hands to the light you see, quantum principles govern them all. Electrons moving through circuits make computers run, photons carry information in fiber optic cables, and semiconductors rely on quantum behavior to function flawlessly. lasers, the tools that read your DVDs or power medical devices, rely entirely on quantum mechanics. Even your smartphone camera sensors depend on particles interacting in predictable quantum ways. Without this knowledge, the world of modern technology as we know it would not exist. Quantum principles also guide chemistry, biology, and even medicine. Photosynthesis in plants, the process that sustains life on Earth, relies on quantum effects to transfer energy efficiently. Drugs interact with proteins based on quantum interactions at atomic levels, and research in quantum biology is uncovering ways that nature uses the quantum world in ways we are only beginning to understand. Quantum computing, still in its infancy, promises to revolutionize computing by using qubits that exist in multiple states simultaneously. This could solve problems that are impossible for classical computers, from climate modeling to drug design. By studying the quantum world, we gain not only practical tools but also a perspective on reality itself. Every device, every light, every reaction in your body is a testament to the hidden quantum processes shaping our universe. Understanding this world deepens appreciation for life, technology, and the cosmos. Section 5. The future of quantum exploration. The frontier of quantum exploration is vast and mysterious. Scientists are probing deeper into particle behavior, seeking answers to questions that have puzzled humanity for decades. New experiments aim to uncover unknown particles, forces, and the ultimate theory that unites quantum mechanics with gravity. Quantum computing is rapidly advancing, promising machines capable of calculations beyond today's imagination. These computers could simulate complex molecular interactions, optimize global logistics, and revolutionize AI. The possibilities seem endless, yet each discovery brings new questions, revealing how little we truly know about the quantum realm. Quantum communication and entanglement are being explored to create unhackable networks, opening doors to a future of secure information exchange. Researchers are even investigating the role of quantum effects in consciousness and biological processes, hinting at a deeper connection between life and the universe's smallest building blocks. The future of quantum exploration is not just about technology. It is about understanding the very essence of reality. As we push the boundaries, we gain insight into the universe's origins, the forces that shaped it, and perhaps even the nature of existence itself. For those who study and wonder, the quantum world offers endless opportunity. Each experiment, each calculation, each observation is a step toward uncovering the hidden rules that govern reality. The adventure continues, and humanity stands at the edge of discovery, ready to explore the unknown and illuminate the invisible. As we conclude our journey into the quantum core of the universe, it's clear that even the tiniest particles hold immense power and beauty. Quarks, electrons, photons, and the forces binding them form the invisible scaffolding of reality. Each particle, each interaction, contributes to the grand story of existence, linking the microscopic to the vast cosmos in seamless harmony. We've seen how quarks dance within nuclei, how electrons orbit in elegant clouds, and how fundamental forces quietly shape the cosmos. We've glimpsed quantum oddities, superposition, entanglement, and tunneling that challenge our intuition and reveal the universe's hidden complexity. In every unseen corner, the universe whispers its secrets, inviting us to explore, learn, and marvel. Understanding quantum physics does more than teach us science, it inspires awe and connection. When we see how the smallest building blocks interact to create everything, from the stars above to the technology in our hands, we gain perspective, a sense of wonder, and respect for the intricacy of existence, the universe, it seems, is alive with subtle motions and quiet interactions. Even in its smallest elements, there is beauty, order, and endless fascination. By exploring these particles and forces, we step closer to comprehending the vast, interconnected tapestry of reality. If this journey into the quantum core inspired curiosity or wonder, take a moment to explore further. Watch more, read more, and keep questioning. The universe is vast, mysterious, and endlessly beautiful, and understanding even a tiny part brings extraordinary insight. Don't forget to like this video, subscribe to the channel, and join us for more calm, educational journeys into the wonders of science. Your curiosity fuels this exploration, and together we can continue uncovering the secrets of the universe, one particle at a time.